Hi, so today we're going to talk about pH, acids, and logarithms, otherwise known as logs. pH, as you might know, is you can think of it as to the power of H. pH, power H. Now pH, of course, H means hydrogen ion, a hydrogen ion, which is H plus. Um, So that would be the H that the power of H is talking about when we talk about pH. pH is the measure of acidity in an aqueous solution. The values of pH range from 0 to 14. So a pH number, you're not going to have like pH 236. You're only going to have a pH 0, a pH 1, a pH 2, and all the decimal points in between. You could have a pH 1.2, a pH 1.75, all the way up to 14. Now the pH values are based on the amount of hydrogen ions present. And as you can see here, let me get this. As you can see here, the hydrogen ions, and the hydrogen ion is 1 plus. So it has that one positive charge to it. So, and that's why the hydrogen ion is so important. The hydrogen ion is repeatedly used in a lot of chemistry examples, so you might as well get used to it now. So, but the hydrogen ion, uh, the amount of hydrogen ions present in the solution, that is how pH is measured. That's what pH is measuring, because hydrogen ion is acidic. So it stands to reason that the more hydrogen ions in the solution, the more acidic the solution is. Now, pH and the hydrogen ions, the amount of hydrogen ions, they have inverse values. And what that means is that, I set up here the pH values range from 0 to 14. So when hydrogen has like the maximum amount, that's going to be pH, that's going to be closest to pH 0 when hydrogen ions have the maximum amount. When hydrogen ions have the minimum amount, that is going to be closer to pH 14. And you'll see why. I know it sounds weird. When hydrogen ions are the least, the pH is at its max at 14. When hydrogen ions are at its most, the pH is at its minimum at 0. It sounds like they're backwards from each other. They are, but you'll understand in a minute. I'll explain to you why that is. So pH measures acidity in an aqueous solution. But what does that even mean? What does that even mean? pH measures acidity in an aqueous solution. So an aqueous solution is a solution that's made of a substance plus water. That's where the water is why it's called aqueous instead of liquid versus liquid. It's not called liquid, a liquid solution. It's called an aqueous solution. And the reason why they call it an aqueous solution is because the solvent is water in the solution. So water, H2O, is probably going to be the main ingredient in the solution. So when you put a solution together, when you put the solvent plus the solute together, the solute, wait a minute, solute is the substance, plus the solvent, which in case of an aqueous solution, that is water. When you mix those together, the ions that make up some of the molecules in that solute are going to break apart and become free-floating ions. When the solute, let's just say, for example, salt and water. When you go to make salt water, you add salt to water. Now, the molecules in the salt are going to combine with the molecules in the water. And when that happens, it causes some of the molecules to break apart into their individual ions. Just because of the way chemicals bond. Like you could bond with half of a molecule and leave the other half of the molecule by itself, and so that half of the molecule happens to be an ion, and so now you have free-floating ions. And you'll see what I'm talking about in a minute. If that's not clear, don't worry. You'll see what I'm talking about in a minute. Now, the main ions that we're going to worry about in this subject, in the subject of pH and logs, are the hydrogen ions, which is a +1 charge, and the hydroxide ion, which is a -1 charge. All right. And if you look at up here is H2O. You have 2 hydrogens and an oxygen. H2O. Now when you break that apart, you got to break them apart. You can't break them apart evenly because the oxygen can't split in 2. It's only 1 oxygen. So you got to just break them apart where you can. So you end up with part of that molecule, that water molecule, is now an ion, the OH ion, which is a negative charge, and the other part of that water molecule that's left over is a hydrogen ion, which is a positive charge. And see, the star of the show, really, when you think about it, because we're dealing with aqueous solutions, which are solutions that are made with water. So the star of the show is H2O. That's water. And here is water being the celebrity, coming out on the red carpet, being photographed. All the fans are cheering for her. So that's water. And that's H2O. And water is what defines an aqueous solution. So we know it has H2O in it. But see, when water needs to break apart, when it's added, when the solute is added to the water and it causes these to break apart, it breaks apart into 2 lopsided molecules. And I say lopsided just because this has 2 atoms to it. This has a hydrogen atom and an oxygen atom. An oxygen atom, or an oxygen ion, by itself is +2. Or no, I'm sorry, -2. My bad. A hydrogen ion by itself is +1. So if you take away the -2 from the +1, then you end up with a -1 charge for this whole thing, this OH. And that's what we call hydroxide. That little ion right there with charge to it, the -1 charge, is called hydroxide. It's 1 oxygen and 1 hydrogen ion. Now this other thing left over is 1 hydrogen ion. Because out of water, H2O, there's only 2 H's and there's only 1 O. So the only thing left is this hydrogen ion. Hydrogen ion. It has a +1 charge. And which makes it an ion, and that's left alone when the water molecule breaks up. Now here's them without their adoring fans. Here's the hydroxide over here. That's OH. And here is the hydrogen. ion, which is plus. Now the hydrogen ion, so you know, that's the acid. The hydrogen ion is always acid. When you see a hydrogen by itself, especially a hydrogen ion, think acid. If you look at all of your acids that you know, like hydrochloride and everything, they all start with an H. It has that H ion in it, hydrogen acid. So what does that make hydroxide, this one over here, this with this negative charge to it, this OH negative? So that makes it basic, or it's also called alkaline. So basic or alkaline is the opposite of an acid. I'll just circle that because acid was circled. So alkaline is the opposite of an acid. So the more hydrogen ions you have in the solution, the more acidic it is. And the more hydroxide ions you have in a solution, the more basic it is. Because hydroxide and hydrogen ions are always they're always opposing each other, their amounts. So if there's a lot of hydrogen ions, there's not going to be a lot of hydroxide ions, and vice versa. So they're just kind of polar opposites of each other. So if there's a lot of hydrogens, there's not going to be a lot of hydroxides. Or if there's a lot of hydroxides, there's not going to be a lot of hydrogens. So you can pretty much assume, and we'll go more into this later in a second video, but you can pretty much assume whatever the amount of hydrogen ions there are equals the inverse amount of hydroxide. And as I said, we'll go more into this in a second video after this one. So the hydrogen ion, and I just went over this, the more hydrogen ions in a solution equals the more acidic the solution is. So hydrogen is the acid. Now the hydrogen ions in a solution is measured, or the measurement is expressed by moles of hydrogen ions per liter of solution. So that's down here. Hydrogen ion, positive hydrogen ion, moles. So the number of hydrogen ion moles in a liter of the solution. Okay, so that's how hydrogen ions are expressed. And you'll need to know that for this next thing. Now, the range of hydrogen moles per liter, the maximum is 1 mole per liter. It sort of maxes out at that point. Like if there's 1 whole mole of hydrogen ions in a liter, then it's kind of saturated with hydrogen ions, and it's probably like blood from the alien monster on Aliens that eats through everything, really acidic. So the maximum is 1 mole of hydrogen ions per liter of solution. Put solution. Now the minimum, it goes all the way down to, the range goes all the way down to 0.000000000000001 mole of hydrogen ions per liter. Now, if you were counting along, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 10 to the negative 14th amount of moles per liter. So if you're not following this, go to my channel and watch my videos on scientific notation, okay? Because scientific notation explains what we're doing here with the 10 to the negative 14th and the 0.001. If you're lost, then go to my page and watch my video on scientific notation. But I'm going to assume you know what I'm talking about with this. So this is 10 to the negative 14th mole of hydrogen ions per liter. Now the negative 14, remember, it doesn't mean that there's a negative amount of hydrogen ions. The negative 14 just means that it's 14 zeros away from the decimal point amount of moles. So that's just a teeny, teeny, tiny amount. Now, 1 whole mole, remember that's the maximum. Maximum is 1 mole of hydrogen per liter. 1 whole mole of hydrogen per liter would be written in scientific notation, would be written as 10 to the 0, because any number with the exponent of 0 equals 1. Remember? If you don't remember that, then go back and look at some of my math videos. So I'm going to assume that you know what I'm talking about. So 10 to the 0 is the maximum hydrogen ions per mole in the mole moles of hydrogen ions per liter. Excuse me. And then the minimum again is 10 to the negative 14. That's what this is. Or what technically we would say 1 times 10 because this is a 1 down here. If this were a 9, then it would be 9 times 10 to the negative 14th. So, but it's not. So it's 1. So I just say for short 10 to the negative 14th moles of hydrogen ions per liter of solution is the 1 times 10 to the negative 14th. Now the reason why I'm going over this so hard and so repetitively is so I can drill into your head this 10 to the 0 and 10 to the negative 14th. It doesn't mean there's a negative amount of hydrogen ions. It just means it's that tiny past the decimal point, 14 zeros. And it's that small amount of a mole of hydrogen ions in the liter of solution. So if I can drill those into your head, then you can follow me to the next slide. So here we have this again. I wrote this up here just so you could refer to it. Now, so here's the 10 to the negative 14. That's the tiny amount of hydrogen ions in a liter of solution. Here's 10 to the 0. That's the maximum amount. That's 1 mole of hydrogen ions per liter of solution. That's the max. Now, here we go. Here's how it ties into pH. pH is measured. What pH is, it's just the exponent of this 10 to the whatever. So this is 10 to the negative 14th. This is 10 to the 0. Those exponents, that's what the pH is without the negative sign. So you want to take away that negative sign from negative 14. That would just be pH 14. If the amount of hydrogen ion concentration is 10 to the negative 9th, the pH would be 9. So the pH is just that number, that exponential number on the 10 without the negative sign. So here we go, the power of 10. Let's talk about logarithms. Switch gears for a second and talk about logs. So what we were saying before is whatever this, if this is negative, then it's going to move the decimal point to make it smaller. And it's going to move the decimal point, or it's going to add so many zeros after the decimal point to make it smaller. And it's going to add so many zeros to make it smaller this many times, 7 times. So Here's the decimal point. 1, 2, 3, 4, 5, 6, 7. So this last number right here is just going to be the 1, because remember this total thing is 1 times 10 to the negative 7th. If this were a 9 times 10 to the negative 7th, this would be a 9 down here. So let's erase this. Okay. So this is going to be 10 to the negative 7th, right? Because there's 1, 2, 3, 4, 5, 6, and the 7th is that 1 we put right here. Now, in the 10th, this is going to be the same thing. In the 10 to the negative 7th, this negative 7 right here is called the log of something. So anytime you have like a 10 raised to something, I'll just put x up here, this exponential something, x would be the log of it. And in this case, in 10 to the negative 7th case, the log would be, or the log would be the negative 7, and it would, the answer would be 10 to the negative 7, the answer would be this over here, 0.0000001. Now, if this is called the log up here, this negative 7, the exponential, this 10 is called the base, just some math terms that you need to just kind of tuck in the back of your head. This 10 is called the base. What is this over here called? This 0.0000001. The true written out translation of 10 to the negative 7th. Well, if negative 7 is called the log, this answer right here is called the anti-log. Okay? So written out in scientific notation, if you take scientific notation and actually write it out, if we're just dealing with ones, mind you, then that's called the anti-log. And then in scientific notation, whatever the exponent is, that's called the log. And here we go again. See, 0.0000001 is equal to 10 to the negative 7th. That negative 7th is the exponent. So that would be the log. This would be the anti-log. So what you're going to do on a calculator, if you're asked to find the log of something, which here's the log of something, but if you're asked to find the log of something, which here's what the problem would look like if you're asked to find the log of something, you wouldn't know what this answer was. And you would just know, you would just have this anti-log information. So what you do is you punch in on your calculator the function log, and then you type in the anti-log, push equals, and you end up getting the log, which is negative 7. So now here's the kind of calculator that I have. Hopefully you have a really similar calculator. If not, this is probably one of the best calculators that in my experience, I've dealt with to do chemistry problems in math and statistics. It's not a graphing calculator, but I think that's a good thing because I think that I want to learn how to graph on my own with actual graph paper so I can actually understand it better instead of just plugging numbers into the calculator and having it graph it for me. So I don't go with the graphing calculator. But I go with this one. You can get this in the bookstore. And this is the basic one I think that chemistry teachers recommend that you have for their class anyway. So if you look at this calculator, say we want to find this information. We want to type in the log, and here's the anti-log right here. And you want to find out this information. You want to find out what is the log. So what is the log of 0.0000001? That's what this question is asking up here, this linear equation. This question is asking, what is the log of 0.00000001. That's what this question up here is asking, and that's what the parentheses mean. So find the log of these numbers, this anti-log inside the parentheses. So what you're going to do on your calculator to find this is you're going to select log on your calculator first. Now my log, if you can see right here, this is where log is on my calculator. And yours might be different. If yours is different, you're always welcome to contact me or talk to your professor, and your professor can probably look at it, bring your calculator in, and your professor can kind of help you, kind of figure it out with you probably. But here's where log is on my calculator, and you notice there's two labels on this button. There's the ln, and then there's log. Those are two separate things. Those are two separate functions. The ln means linear or something. I don't know, or line log or something. But log is a second function on here. So what I do is I just push this button twice. If you push the button for one time, one time, the line will come up, the ln and parentheses will come up. So if you push it a second time, the ln will change to log and a parentheses will open up. So it would be up here. It would look like if you push to this button twice, it would say log and then parentheses would open. So when the parentheses opens, within that parentheses, enter that anti-log, that 0.00000001. And you can close the parentheses. You really don't have to. The calculator just assumes that you mean close parentheses if you just hit equal. And then you go down here and you hit equal. And it will give you the answer -7. So the log of 0.00000001 is -7. Now the log, the -7 that I'm talking about, if you just get rid of that negative sign, because it's always going to be negative in these problems that you're doing with finding acids, it's always going to be a negative something. So if you just drop that negative, the pH is the number with the negative dropped. So the pH is going to be 7. Now not -7. The log is -7. The log is -7. But the pH is the log without the negative sign. So that's just 7. And it's really as easy as that. You just find the log of something, you type in log and put in the number in the parentheses and you hit equals. And it'll give you like a negative number in these specific instances when you're studying pH and logs. It'll give you a negative number. You just drop the negative sign and whatever the number is, that's your pH. And what is that anti-log that I've been talking about? That 0.00000001 that we're trying to find the log to, we're trying to find the pH to, if we drop that negative on the log. That whole anti-log is the hydrogen ion concentration. Remember, to bring it back to what I was talking about earlier, the hydrogen concentration and those brackets around the hydrogen ion just mean concentration. The hydrogen concentration is just the number of hydrogen moles per liter of solution. So this hydrogen concentration is the anti-log. The anti-log is that long 0.00001 number. So you could technically say that, oh, I ran out of places to write. Hold on, let me change colors so you can see this. So you can technically say that the anti-log equals this. Now that's the symbol for the hydrogen ion, the H plus, and then those brackets around it just means concentration. So that would be the same thing as the number of hydrogen ion moles per liter of solution. So I hope you can read that. I ran out of space. So the power of 10 pH and logs. This is going to be this anti-log and this is going to be the log. And this doesn't just go for pH, this goes for any scientific notation. This goes for any power of 10's exponent after a 10. If you have 10 as the base, whatever the exponent is going to be the log. And whatever that actually, if you write it out long form, whatever you write it out long form to is going to be the anti-log. And then the log without the negative sign is the pH. The anti-log is the same thing as the hydrogen ion concentration. And these brackets mean concentration. So you're going to see problems like what is the pH of hydrogen concentration of I don't know, 0.001. So you're going to write the hydrogen concentration. The concentration is these brackets. So the hydrogen concentration is 0.001. So in between those brackets, you're going to write 0.001 equals 10 to the what? And it's going to be a minus what? And whatever that question mark is without the minus sign, that's going to be your pH. And if you join me in the next video in this little short series here, I'll go over practice problems and everything with you so you can see exactly what I'm talking about. You can learn to use your calculator a lot better and get used to it. We'll be converting pH to hydrogen concentrations, and we'll also be going backwards both ways. We'll do hydrogen concentrations to pH, and we'll also do finding if you have the pH, finding the hydrogen concentrations. So join me in the next video.